So hello guys, my name is Pablo Erhard and I'm going to give you a brief introduction to our topic, binomial distribution. It's really simple. So first of all, you need to understand that n equals number of trials. Well, before this I need to tell you that this is a random experiment that only has two outcomes, success or failure. Every trial is independent. Those are the main things you need to know. So first of all, we need to understand what the formula consists of. N equals number of trials. Uppercase letter X equals number of successes. P equals probability of success. Q equals probability of failure. So here we have two formulas, which is a math differentiation formula. You need to understand that these two are basically the same, just written different. I'm going to explain the first one. So P, uppercase letter X and equals lowercase letter x, equals n combination x times p to the x power times parenthesis 1 minus p, which is probability of success, to the n minus x power. So I'm just going to quickly explain what 1 minus p means. Imagine we have a probability of success, which in this case is p, of 0.5, which is the coin toss. Imagine we have tails or heads, which is, imagine we have the 0.5% chance to either have head or tails. So in this case our success would be heads. That's what I want to show. So imagine we have 1 minus our success, which is p, so 0.5. This will give us 0.5 as well. You guys need to understand that this 1 minus p equals q, which is our probability of failure. It's very important for you guys to understand it. Once you already know these formulas, you need to know that ex equals the number of trials times the probability of success. Then variance of x equals n, which is number of trials times probability of success, times probability of failure. Then we have the standard deviation formula, which in this case is the square root of variance, which is n times p times q. So this is only a brief introduction of what the topic consists of. Eduardo and Fernando are going to give you a brief example as well, how you apply these formulas and how you understand to take out number of trials, to find number of success, and the probability of success and probability of failure as well. So thank you for listening, and you will hear Fernando next.
I'm Fernando Las, and I'm going to explain to you how to solve problem number 13 for our project. So, starting with the problem. A toolbox with 90 screws, 9 of them are defective, and question A asks us to get 5 that are defective out of random, pulling them out randomly. So what we have to do is this. We use combinations. So 5 combination 5 times 0.10, which is our success rate, because we have a success rate of 10%, because 9 out of 90, it's 10%, and our failure rate. Our failure rate will be the rest, which is 90%. So how many do we want to get out of 10%? We want to get 5 screws. We don't want any of these. So we do this. 5 combination 5 times 0.10 to the 5th times 0.9 to the 0. We put that on the calculator, and we're gonna get the answer, which is 1 to the 10th to the negative 5. And for problem B, asks us to get 5 good screws. So it's gonna be the same thing, but now what we're gonna do is we're gonna switch up the 0 and the 5, because since now we don't want any bad screws, this 0 that's over here is gonna go over here, and this 5, because now we want 5 good screws, it's gonna go over here. So it's the same problem, 5 combination 5 times 0.10 to the 0 now, and times 0.90 to the 5th now. And our answer is going to be 0.59049, so 0.59, 0.60 if you want to say. And what we normally do to get the answer for this is we look for our n's. Our n is our sample size, yeah. So our n will be 9. Will be 9. Our p, which is our success rate, will be depending on which problem we're doing it. I'm doing it for A right now, will be 0.10. Our Q will be 0.90, because if our P is our success rate, our Q will be our failure rate. And yeah, so now that's for problem A. And for problem B, I'm going to do it here. Our n is going to be 5. N will be 5, because we're taking out 5 screws. We're taking out 5 screws out of each, so that's why our n will be 5. Our P will equal 0.90, because now our P is going to be our success rate on letter B, because we're looking to take out 5 good screws. And our Q will be 0.10, because that's our failure rate. So this will be how you answer this problem. P 10 Q 0.90. This is how you answer these, the A and B from problem number 13. Thank you.
The first step is using 5 combination 5 multiplied by the probability of 0.1 to the 0 power. This is because we need to find that at least 4 are good. So we need to take in count the 4 and the 5, because our selected variable is 5. So at least 4, it includes 5 also. So 5 combination 5, we don't have this probability, so it's to the 0 power. So all the powers goes to 0.9. This in the calculator gives me 0.59. And then we need to add it to the 5 combination 4. This in the calculator gives me 0.33. Now if we add it in the calculator, 0.59 plus 0.33, it gives me 0.92. So the probability of getting at least 4 is equal to 92%. Now we are gonna do letter D. In this problem, they ask us that what is the probability that at most 2 screws are defective. So we basically need to do the same as letter C, but the other way around. We want to know what is the probability that 2 are defective. So we do the same thing as the past example. We do the 5 combination 0, because 0 is also a part of the probability. 5 combination 1 and 5 combination 2. We are also taking 2 in part because it says at most 2. So like here, we want the same as 2 or less. So it's 0, 1 and 2. This is the answer of these problems, and we add up all the probabilities of this, and we get that the probability to get in at most 2 defective is 99%.